I haven't unmuted again. I've got to learn to do that. I've got a big sign saying first thing I should do is unmute. And that's not a great start. Let's start again. Good morning. Welcome back to Mr. Harris School of Maths. Hopefully you've had a good day yesterday. It's not too bad being stuck indoors. Thank you so much for joining in, and hopefully I'm going to manage to, tomorrow we'll try and live stream one where I actually get the sound working straight away. So let's get cracking. Today we're going to look at special numbers, and we've got a bit of a starter. Yesterday I asked people to go to Corbett Maths. So what I'm going to do is just look at the things that we did yesterday. Hopefully I'm in the way at the moment. So hopefully that should now be working. Right, these are the answers to the Corbett Maths from yesterday, the primary 5-a-day for the 24th of February. This is what I suggested people did, and what I've done here is put the answers up so that anyone who did have a go can check their answers off against these answers. They have got answers on there, so you are able to do this, but just in case anyone wanted to, you can see I've shown as much working as I can. I've circled down the bottom where the Thursday answer comes from because it's the highest number on the graph. And these 5-a-day give you something to do each day. You can do the different medal values, and hopefully you'll be able to get a little bit of maths. Now let's move on to today. We're going to be talking about different types of numbers. There's lots of different types of numbers out there, and I'm going to be trying to talk about as many different types as we can. What makes them interesting, what makes them special, and I'm going to try and make it interesting for everyone. So these are some different types of numbers. Basically, we've got evens and odds, lots of people have heard of. Multiples we've talked about this week already. So the times tables, the multiples are the times tables. We've got triangle numbers, which came up the other day, where you can make triangles out of the numbers. So you've got 1 and then 3, and we've got different triangle numbers you can make. And so that might be useful to know about later. We've got square numbers, which are different types of multiplying a number by itself. Integers is just a long way of saying whole numbers. So they're just the whole numbers we're going to be trying to use. Cube numbers are where you times a number and times it by itself again. So 2 times 2 times 2, which makes 8. 2 times 2 is 4, times 2 is 8, is a cube number. Anytime you take a number and times it by itself. The next one I think is 27. 3 times 3 times 3. Now Fibonacci numbers I'm going to talk about later in the video. So hopefully we'll learn something about those. Prime numbers are special numbers which I'm going to talk about in a second. There's also, you can see, reflectables, and some of the A-level students even talk about imaginary numbers. We're not going to talk about those now because they're very complicated. They make even my brain hurt. But they're a type of numbers too. Let's have me back. Hopefully, by magic, I'm now on your screen again. So, I am going to quickly talk about, we've talked about even numbers. They're the numbers 2, 4, 6, 8, 10, and they go on like that. We've talked about odd numbers, 1, 3, 5, 7, 9. But my year 5s and 6s and some of the younger ones as well will actually want to do something harder than that. Prime numbers are numbers that only divide by 1 and themselves. So, for example, 2, you can't make 2 with any numbers inside it. But 4 you can do as 2 times 2. So 4 can't be a prime number. They're called composite numbers. You have prime numbers, which you can only make using 1 and themselves. And then you have composite numbers, which you can make by timesing 2 numbers together. Maybe you can think of some other composite numbers. I think my favourite composite number is probably 14. And that's 2 times 7, but it's got 1 times 14 and 2 times 7, but the 2 times 7 makes it a composite number, not a prime. We've then got square numbers. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, and it goes on like that. We've got triangle numbers, which are the numbers we can make into triangles. We've got 1, 3, 6, and it's making little triangles. And then the next one, we've got factors. Factors are numbers that go inside a number. For example, the factors of 20 are 1 times 20, 2 times 10, and 4 times 5. So they are all the numbers. We've also got multiples. We talked about multiples on Monday. Multiples are just a posh word for the times tables. So the multiples of 3 are 3, 6, 9, 12. The multiples of 11 are 11, 22, 33, 44. So we can use all of that things to help us with the first activity in our word search. If you go into the comments at the bottom of the video, you can find a link to this word search. So if you've got chance, pause the video and print it off. Maybe some of you have already found it and printed it off. At any time I have resources, I will try and share the resources in the Facebook group before the lesson, so that if you want to go and get everything ready, you can have the resources ready to use. But I never told you how to use it. What you're going to need to do is you're going to need to find 6 even numbers, 6 odd numbers, 6 prime numbers, 6 composite numbers, 6 square numbers. But the way we do this is in a row. Oh, I'm in the way. So let's hope I've disappeared now. I've got to remember to make myself disappear. Composite numbers, 6 square numbers, 6 triangle numbers, 6 factors of 12, and 6 multiples of 5. But they're the first ones. If we go to the top corner of this grid, the top left corner, and look diagonally, we can find 2, 4, 6, 8, 10, 12. So you can put a line through the first 6 even numbers, and that would help you with finding the numbers. If you'd like to complete the grid now, you can pause it. But if you don't want to and you want to wait, this is a perfect activity to do once the video ends. You can see if you can find them all and send me a picture on the Facebook group, or to the normal places, the Twitter account, or to just post a comment here, and you can tell me that you've managed to complete the grid. Anyone who needs some help, these are the first numbers. Try to do it without cheating, but if you wanted to, you could come back and look at these numbers here. If you are stopping the video, that's absolutely fine, but I'm going to carry on anyway. And it's got to come back to me now, so hopefully I've reappeared. I have to check because I'm still not trusting that the video is doing what I want it to. The next thing we're going to look at is the number grid that is on the worksheet that I gave everyone. The number grid has some different properties that you need to find numbers that fit. But I've got some numbers for you, so you can't do it yet. Anyone who's trying to jump ahead, you've got to wait until I have finished showing you the properties, because if I go forwards, these are the numbers. One of these numbers goes in each box. One of these numbers gives a remainder of 3 when divided by 7. One of these numbers has a product, is the product of 6 and 7. Product means times. It's another special number. Products are when you times 2 numbers together. A prime number that is less than 10. A common factor. Common factor, we didn't mention those. Common factors are numbers which are factors of one number and another. For example, 1 goes into 12 and goes into 18, but 1 isn't in this list. 6 goes into 12 and goes into 18, but it isn't in this list. So one of these numbers will go in that box. The difference between the 5th square number, that's 5 squared, and the 6th squared number, 6 squared. Find the difference. Difference, we have to think about what that means. Common multiple. We talked about common factor a minute ago. Common multiple. That means it's in the 5 times table and the 8 times table and the 10 times table. These numbers can be put in, but feel free to pause the video and do that now, or you can wait and do it after the video finishes. You can always come back to this screen afterwards, or the resources are on the worksheet that I mentioned earlier. Hopefully that has helped some people to have something more interesting to work on. A 2-digit number that is divisible by both 2 and 8 means it can divide by 2, it's in the 2 times table, and it can divide by 8, it's in the 8 times table. So see if you can work that out, and I'd love to see your pictures on the Facebook group of all the answers you've got to that question, or those questions. Hello again. Okay, so we've already got lots of stuff done, lots of things to do. Some of you who want to get on with things, I understand, may have already paused and finished this work. I understand. I'm trying to make it interesting for you. I'm trying to make it enjoyable. I'm aware, though, it's a bit sad. I don't know if any of you have been watching the news, but I just want to talk about one thing that I saw in the local news. Unfortunately, last night, the police dog centre around the corner from me, they had a break-in, had a robbery, which is really sad, isn't it? At the moment, the police say they've got no leads. Okay, let's talk about the Sieve of Eratosthenes. What on earth have I just said? The Sieve of Eratosthenes is a way of finding prime numbers. Prime numbers are, I have just noticed in the chat, someone has just mentioned what reciprocals are. I will come to that in a second. Prime numbers are found and by using this special method I'm going to talk you through. What you do is you write down all the numbers from 1 to maybe 80, that's what I put on the sheet, or 100, or you can write down all the numbers. Then we ignore 1 because 1 doesn't count. So let me reach over and grab this. If I had the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12, and it would look a bit like this. But I'm going to hide behind it and poke my head round. I'm going to cross out 1 because we don't want to work with that one. So, we're going to start the Sieve of Eratosthenes, which is named after a Greek mathematician, Eratosthenes. I can't say it. Maybe you are better than I am. Just here, we circle the 2. And because we're circling the 2, we're now going to cross out any numbers in the 2 times table. So we're going to cross out 4, and cross out 6, and cross out 8, and cross out 10, and cross out 12. Later, if you're doing this on your grid, you can do this with all of the numbers in the 2 times table. So now I've crossed out all the 2 times table. Now I have to look at the next times table. Well, the next number that's not crossed out is the 3. So because the next number that's not crossed out is the 3, I'm going to circle the 3 and go through crossing out the 3 times table. But the first one, 6, is already crossed out. Don't worry if it's already crossed out, it's already got rid of. But we haven't crossed out 9, so that has to be crossed out. The next thing we're going to look at is the next one that isn't crossed out, not 4, it got crossed out already. So now we've got to cross out the 5. We're going to circle it because it's the next prime number, because it hasn't been crossed off yet, and we're going to look in the 5 times table. Now if you've gone up to 80, there'll be lots of 5 times table that are still there, but 10's already gone. So we're done with that one. 7 is the next one, so we'll circle 7. There's no 7 times table in the first 12, but there will be on your grids. And then the 11, and we're going to cross off all the 11 times table. So you go through crossing off all those times tables until, once you get up, if you're doing up to 80, once you get up to about 17, once you get up to 11, I think, you've found them all. You then go through circling all the not crossed out numbers. And in this way, using the Sieve of Eratosthenes, you find all the prime numbers in a list. And you can do that. I've got a student, Katie, who uses this all the time to find her prime numbers. So there you go. So, I did mention I'd explain what reciprocals are. Reciprocals are special numbers where you multiply by a number. It's what number times is to get back to the other number. So 3 has a reciprocal of 1/3 because it's like the upside down, the inverse of 3. So anytime we've got a number, reciprocals, this is mainly done in GCSE, but it doesn't matter if some people have asked about it. That's what a reciprocal is. It's a special type of number. Okay, let's come out here. So my challenge, you can either pause the video now or wait till the end of the video when I go and you have some time without me being silly. I'd like you to complete the Sieve of Eratosthenes. Again, it's on the worksheet that is attached in the link at the bottom, and you can complete it by crossing out. I'd love to see them. Maybe use different colours for each number you cross out. Maybe make it nice and make it look pretty, and you can have the Sieve of Eratosthenes along the top. Then you can circle and work out all the prime numbers. I'd love to see, if you do this, I'd love to see pictures in the Facebook group. I'd love to see you going and show me what you've done. So, Fibonacci. I mentioned this earlier. This was a number earlier. Who's this Fibonacci guy? Well, Fibonacci, Leonardo Fibonacci, was an Italian man who actually invented the decimal system. Before him, they used the Roman numeral system of I, IV, V. It was very letter-based. And I can imagine doing your sums first thing in the morning in Roman times would have been very complicated. You'd have been, okay, children, can we have quiet, please? What is V times X? And you'd have to... It wasn't as easy as it is now. But V times X is just, what's 5 times 10? And 5 tens is 50. So it's much easier now. Okay, so what is Fibonacci? Well, the other thing he did is he explored nature. He looked around him and saw all these number spirals and numbers in nature. He was studying rabbits, and he looked at rabbits, and if rabbits take 2 months to have little baby rabbits, and they have one lot of baby rabbits, how many more rabbits will there be? And he monitored it on, and he spotted some number patterns. In fact, he spotted this number pattern on the left: 1, 1, 2, 3, 5, 8, 13, 21, 34. He spotted that these numbers seem to appear in nature everywhere. From the branches of trees, from the middle of the... Oh, I've lost the ability to speak. From the branches of trees, from the middle of the plants, in the pollen. He looked at fir cones, and he took a fir cone. If you've got a fir cone in your garden, I don't know if many people have, but if you're able to find one, if you do go for your one walk a day and you get to go through the woods, see if you can find any pine cones, because pine cones have these numbers. If you count the spirals round the outside, it's likely to be one of these Fibonacci numbers. Has anyone spotted the pattern going on here? There is a pattern, and it's just at the bottom of the screen here. 1 and 1 makes 2. That's where the 2 comes from. 1 and 2 gives us the 3. So 1 and 2 is where we got the 3, and you can see the working underneath. 2 and 3 is 5. 3 and 5 is 8. 8 and 13. And that's why the next two numbers that we should have worked out were 55 and 89. Because these numbers, you can carry on going higher. I'm sure some people, I know Xander is very good. If Xander's here today, he'll possibly go off and work out the next ones all the way up to 200. I'm sure some more of you will as well. So, these are the Fibonacci numbers. And you can work them out, and once you've worked them out, they produce something called the golden ratio. What's the golden ratio? The golden ratio is this very, very bizarre thing that was discovered by Leonardo da Vinci. The golden ratio is what happens when you take Fibonacci numbers and you take two numbers next to each other and you divide them by each other. And it is quite bizarre. They nearly all come out, once you get really big, they all come out to the same number. 1.61, the golden ratio. It's bizarre. But you know what's the most bizarre? It's not just those Fibonacci numbers. If you measure the distance from your elbow to your hand and from your hand to the top of your finger, and divide those two numbers, you'll get something close to 1.61. But it doesn't stop there. If you measure the length of your fingers to your elbow and your fingers to the top of your arm and divide those numbers, it will be close to 1.61. If you measure the height from the floor, if I stand up, I'm going to disappear from the screen a second. We've got the height from my belly button down to the floor and the height from the floor to the top of my head, which is off the picture at the moment. Then you divide them and you get something close to the golden ratio. It seems to be everywhere. You can even do it with your arms outstretched and measuring those distances. I wonder how many different distances you can find that give you this golden ratio. It's just crazy that it exists everywhere. And so I'm fascinated by it all. I'm still in the screen. I'm getting better at this. Hopefully by the end of the week I'll be managing to do it without muting myself, and I'll be able to do it so I can get everything working exactly as I need to. So have a look around in the garden. If you have a garden with any plants in it, go and have a look after this live stream and go and have a look at the different plants and things that are available. I'd love to find some pictures like this where you found some plants where these numbers appear and these patterns. I think it's pretty beautiful. I have gone through everything. Hopefully you've enjoyed today's live stream. I hope that you've been able to learn some things about different types of numbers. I hope that you've been able to do some different things, and I hope that you have been able to explore the different numbers. But they've got lots of things to do now. Go back and do the number search. Go back and work out the numbers that go in the grid. Go back and complete the Sieve of Eratosthenes. I hope I've given you lots of fun things to carry on with. I'm going to let you go because there's no point me staying around till 10:30 just because it's 10:30. Let's stop there. That means you don't have to listen to me anymore. I hope you've had a good time. I certainly have. And I will see you all tomorrow.